One and all present here. Welcome to fourth day of International Faculty Development Program hosted by Artificial Intelligence and Data Science Department of Eastern Engineering College. We are delighted to have you here. Today's session is on Vector tool. I take great privilege in introducing Bhubadi sir, Technical Associative Research Lab Bhuj. Completed his MSc from Anna University and has 10 plus years of experience in software engineering and has vast knowledge in data science. And furthermore, has delivered guest lectures in 20 plus colleges around India. We are honored to have you today, sir. I pass the session over to you.
Thank you, ma'am. Thank you. Yes, sir. So can you hear me, please?
Yes, sir.
Please, anyone? Okay. Shall we start session, please? Yeah.
Yes, you can start, sir.
Okay. Okay. Thank you, everyone, to giving this openings. First of all, just I have to thank Mr. K. Raja, Department Head of the Department of Artificial Intelligence, SRM, Mysore Engineering College. So as well as I thank everyone here to are together here. Okay, so now let's start our session. Okay, so today we are going to discuss about that Vega 2. In previously, actually it is that 15 days FTP, international FTP for that. I think the various top represents various research candidates as well as the highest rated students are together here now. I think joined here in this session. Okay, so even though so nowadays the data science is here. Nowadays it's making the more impact in our society, in our technology, something like that. First of all, if you talk about that industry 4.0, so it consists of few technologies. The first one is that cloud computing. The second one is data science. Third one is augmented reality. Then 3D manufacturing. Then something like that. So it is also data science is also one of that very important concerns nowadays, because without data science we can't do anything something like that. So in previously, just we have to discuss about that big data warehousing, something like that. Okay, so even though the lot of tools are available to handling the data science, so even though today our session we are going to discuss about that Vega tool, how we have to handle some large data sets using that Vega tool. Okay, now let's start our session one by one. So today's session we are going to discuss about that. So what is mean by data science, then what is mean by data warehousing and the data mining, something like that. Actually everybody know about that. So even though just we have to give some outline about that data science definition, something like that. Then after that we have to discuss about that Vega tools, how we have to insert that Vega tool, then how to create that files, data sets for our own use. Otherwise, how we can able to either load into the data set to in that Vega tool, something like that. As well as what about that data pre-processing, because it is the one of the major that is playing a major role in everywhere. So that data pre-processing. So then now today's session also just we have to do some practical sessions, how we have to handle the pre-processing. That means how we have to handle that null values, how to replace that some cache, something like that. That is called the data pre-processing. Just we will do that some practical session about the data pre-processing. Then feature selection. Feature selection means there is a attribute selections. So how we have to, which are the most important attributes are playing for the output, something like that. Then we have to check out classification algorithms, then clustering algorithms, then what are the regression algorithms, something like that. So these are we are going to discuss in this session. Okay, so just we go for that. So this everybody know about that. What is meant by data science and what is meant by data analytics, something like that. So that means data science means so it is a meaningful correlation between the large data sets. So everybody know about that. Data science means it is just we have to find out the correlation. That means the relation in between that relation was what are. So how just we have to find out the relationship in between the data in that large data set, something like that, which is called the data science. So here also they are given some more points about that. The data, what are the main role of it nowadays in industry? Just we have to classify that such a domain in two categories. The first one is academic based, second one is industry based. So in industry based, nowadays we have to listen about what are various roles are played in the MNC levels. Data scientists, data analytics, something like that. So here I given some little bit examples for you. The data scientist is what their main work of them. Just they are doing that new process for the data modeling. So which is called the data scientist. As well as just come to the bottom side, here I given the data analytics. That means just we have to perform the analysis of data sets, which is called the data analytics. So because today our session, just I have what I feel means just I have to given the full practical session. So that's why just we have to discuss some outline about the theoretical part. Okay, so which is called, everybody know about that what's my data science and the data analytics, something like that. Okay, next we go for that. So just I given that. So not only here I given the some slide. This slide is indicating not only how data mining works. It's defining about how data scientists are working, how the corresponding data analysts are working, something like that. This is a real-time method. That means if anyone company, anyone MNC company is working, is based upon this procedures only. So if you notice this slide, you can able to understand how we have to formulate, how we have to segment some data sets like that. So the first one is in that left side is it is a database. Everybody know about that databases. What is maybe database, something like that. Then data warehouses, then data centers, something like that. So from just we have to collect that data sets from the data warehouses or databases, something like that. So after that, it goes for that clean and collect and clean and store. That means here in the second step, collect and clean and store. Here only just we have to do the data pre-processing. So we will do in practical manner. So just we have to understand what I try to convey that. In the second step, just we have to do the data pre-processing. So that only is just we have to apply that some just we have to do some analysis applications. So here we have to know about that. So what we are doing in analysis space means just we have to perform some queries, some creating some rules, then just we have to do some format data, something like that. So after that, data science is to find out something like that. Just we have to implement some algorithms there. Okay. So after that implementation, if they will get it the correct answer, the right output, so just they will show to them. So otherwise, this go for that review process. Again, this go for that from steps to just analysis process. This is a recycle thing. So this is a corresponding procedures we have to follow when we are working with a huge large data set. Okay, so huge data sets. So these are procedures that we have to follow. So not only data scientists, the data analysts also they are following something like that. So it is the procedures just we have to following that. Okay, now let's go for that. So where we can get some data? Actually nowadays, just I use some real-time examples for you. So nowadays we are working with Facebook, we are working with Instagram. Then YouTube channel, something like that. Just always we are spending lots of more. So just we have to spend a lot of times there. So as well as just we have to. So this is an example for the huge data sets, something like that. Okay. So in that left side, just I given that's where we can get it some data, large data sets means we can get it that some data from the supermarket. then grid call instructions, then calls and records. It's not only like that. Apart from that, just I have to convey one real-time example. So nowadays we are using that Facebook. But day by day, just we have to upload some documentation, upload some videos, upload some photos. So it's everything. This actually. Just we have to think about how many billions of users using the Facebook per day. So how they will handle data. So it is here only just we have to apply the data science concepts, data analysis concept here means. So it is Facebook, then YouTube, then Amazon Web Services. So these are the real-time examples for our huge data sets, something like that. So here, so in the left side concepts is indicating about where we can get the huge amount of data sets from the real time, something like that. Okay, so these are something like that. As well as in the right side, just I given some software packages or software platforms to working with the data science. So the first one is the RabbitMiner. Then Oracle company is producing that Oracle Data Miner. It's one of the real-time software. As well as IBM companies introduced that SPSS model. It is one of the data tools to working with data science, as well as KNIME, then Python, then Orange, then Kaggle, then Ratil. Next one is Vega, then Teradata. So these are the real-time platforms with software packages is dealing with data science concepts. So even though, so today's session just we have to discuss about the Vega tool only. So here, so what is the speciality about that Vega tool means? Just I have to give some outline about that. So always nowadays we are working with Python. As well as working with Anaconda Python, something like that. Just I have to give the differentiation between Vega tool as well as the Python means. Suppose if you are working any one packages, that may be a Spider, or that may be a PyCharm, or that may be that Jupyter. So if you everywhere, just we have to write the coding. For example, just we have to import the packages, import pandas API, something like that. After that, just we have to mention, just we have to load the data set. Just we have to define the corresponding and the location of the data set, something like that. So after that, just we have to check out that is whether the data set consists of any null value or something like that, or mystery value, something like that. So these are the pre-processing steps. After that, we have to call some, suppose if you are going to apply a classification algorithm, otherwise regression algorithm, just we have to import the classification algorithm. So after that, again, we have to import that decoder and the one-hot encoder for that data manipulation some purpose. So after then only, just we have to execute that the corresponding, that may be a classification algorithm, otherwise a regression algorithm. So these are the, just we have to write the, just we have to follow some procedures, as well as write the coding for coding in that Spider or Jupyter. But in Vega tool, it is here pre-defined. It is fully based upon graphical user interface. Just means that means just we have to load the data set, just we have to click and execute. So it is a very easy manner. So there is a very big difference between that Python as well as Vega tool. So what are the algorithms are available in that machine learning or deep learning? So we can able to execute any one algorithms by using this Vega tool. Okay, so this is one of the specialty of the Vega tool. Okay, now we have to let's go for that. So this is that intro about the introduction about the Vega tool. So in the first one thing, the Vega tool is a consisting of a collection of machine learning algorithms as well as deep learning algorithms. So we can able to execute any one algorithm by using this Vega tool. As well as actually it is invented in New Zealand. That means Waikato Environment for Knowledge Analysts. So it is invented in Waikato University, in New Zealand. So it is the so it is that overall about that Vega tool. So even though it is written in Java programming, but we can able to execute anyone. So we can able to. So actually, if you are a Windows player, you can able to download the exe file. Suppose if you are using that Linux or Unix experiment, just we can able to install in the Linux or Unix. Okay, so it is the Vega tool it's able to work in any one platform, as well as just the corresponding that table is indicating about that. So it is using that 75 different techniques for data pre-processing. Okay, so nowadays what we think means that data pre-processing means just we have to find out that null values, just we have to using that attribute selection, and just we have to replace the value with replace the attributes with the value, something just we have to fill that. But even though the corresponding Vega tool is support that 75 different techniques for the data pre-processing. So as well as it is supporting that in recursion and classification. It is supported 100 plus algorithms for that recursion classification for supervised method. So everybody know about that. So what is supervised learning? So what is unsupervised learning? The labeled data, unlabeled data, something like that. So which one algorithms are applied on that labeled data, which is called that supervised learning, something like that, because everybody know about that. Okay, so here this Vega tool became able to access 100 plus algorithms in the supervised learning method, as well as its Vega tool support that 20 plus clustering algorithms for that. So after that, feature selection. Nowadays, the various research papers are published in the data science, in data mining, something like that. Just that means ensemble learning algorithm use with feature selection applied in IDS, applied in health sector, something like that. So feature selection means it is that just we have to choose the attribute selection. So what are the most important attributes are played in the data set? Just we have to capture that most important attribute, and then just we have to execute the data set. So this is the feature selection. So it is the corresponding Vega tool is executing that 25 feature selection process. Okay, so the as well as association rules. So it is Vega tool is incorporated with the 3 algorithms. That means this execute the 3 association rules in that platform. So these are that just the introduction about that Vega tool. So as well as we can able to apply this Vega tool in various application. Okay, then in that right side, just I given that various applications. Just that's why that means we can able to apply on that customer segmentation, then financial analysis, then fraud detection, healthcare data analysis, manufacturing engineering, corporate surveillance, scientific research. That means here this application is nothing but we can get it more data sets from the various applications. Sometimes we can get it some data sets from the medical field. Sometimes some data sets we can get it data sets from that IDS and cyber physical domain, something like that. So we can be able to execute any type of any one data sets using the Vega tool. Okay, so now let's go for this. I have to show the real time how we have to work with Vega tools. Just I go for. So I already installed that Vega tool. So currently nowadays available that Vega tool is Vega 3.8.6. So it's loading there. So comparing with the Vega tool, comparing with the Python or Anaconda Python, it takes some more time. Okay. So now we got it. So this is the framework of Vega tool. So this is that recent version, the version 3.8.6. Nowadays it's available. That it is a free source platform. So just you go and browse in Google. Just you can get it. You can able to download it, this Vega tool in Google browser. Google site. So it is a version 3.8.6. Just I have to convey one thing. Suppose if you are having any one old version of Vega tool in your system, it does not support the current features. So that's why just you have to update your Vega version to current build. Okay. So in the top things, in the top domain, these are the tools. These are the tools are working with that Vega platform. In that right side, these are the applications. Just I will explain one by one. Just for know for that, the corresponding, if you click the program, the log windows, it is shows about what are the just I will show that here. Yeah. So here, still now we didn't execute any one program. That's why it is blanking. That means it is show what we are doing. So we suppose if I are executing any one program, any one algorithm, something like that. So it will indicate in that log window. Then go for that visualization. So it is the most important one thing, visualization. Suppose if you want to write the plot diagram, then ROC. So ROC means it is that indicate about the performance of the corresponding data set. Then decision tree, then graph visualizer, then found visualizer. That means suppose we want to execute, if we want to see about that one data sets visualization means just we have to do some, just we have to execute from here. Okay, visualization. Next to go for the tools. So corresponding this package manager, it is a main thing, one thing. So package manager means suppose if we want to install any one packages, because the Vega tool having the lots of packages like that Python. So suppose if we are having that Python means we have to update to the current version, and we have to if you want to install any one packages means suppose for Jupyter or a Spider means just we have to install that in that Python programming. So Python environment like that. Here the Vega is also having the lots of packages. Suppose if you want just we have to go to the package manager and install it. Just a minute, it's yeah, it's loading here. Yeah, just made it is established again. Now only just you have to download the every packages. Okay, so now I think it will take some more time. Yeah. So okay, next we go for that again. I will go for the applications because we have the short amount of time. So this is the Explorer. In the right side, we are having that lots of applications. So we have 5 applications. The first one is Explorer. Just a minute. Yeah. Yeah. So these are the packages. Here, now we can able to find out. So suppose what are the packages installed means here indicator install that. So available means this one is available. Suppose if you want to anyone packages have to install means just we have to click with anyone Auto Vega something like that means okay. Just we have to install that, no problem. It's automatically install that. So it is that now if we press the installation button, automatically install that. Okay. So like that Python, it is the corresponding Vega is also having the lots of packages for a specific purpose. Like that Python, because if you just we have to import that NumPy for the mathematical work. For the visualization, we have to import the scikit-learn and the sequence, something like that. So like that, the Vega tools also having a lots of packages. So these are the packages. Okay. Okay. Now let's go for that. Just a minute. Explorer. So these are one of that application. Already it's opened here. Yeah. So this is that framework of that Explorer. So here in this framework, just I give some outline. So in this framework, we have to execute, load any one data set here and execute means just we have to apply any one algorithm. There may be a supervised algorithm, there may be a unsupervised algorithm, there may be a deep learning, something whatever may be. We can able to load and execute that algorithms here. So this is called that Explorer. Next, suppose I will give the qualification after that. Now just come for that experimenter. Yes, mate, it will take some more time to, yeah. In that, what is the difference between that Explorer and the experimenter means? In that Explorer, we can able to give only one algorithm. Suppose if you execute, if you have to find out F1 score or accuracy or performance, something like that means we can able to execute only one algorithm in that Explorer. In that experimenter, sometimes what we feel means why not we compare with various algorithms at a time? So suppose nowadays lots of research papers are available, lots of research going on that. Just we have to apply. Just we have to take that only one data set, and we have to apply that lots of algorithms. That may be a classification algorithm, that may be a regression algorithm based upon the conditions, based upon the data sets. Okay. So here, so that experimenter is will show that. That means here we can able to apply that more than algorithms in only one data set. Okay, so that then only we can find out which one algorithm given the more accuracy, which one algorithm given that more F1 score, something like that. Then which one algorithm given that correlation coefficient, correlation matrix, something like that. So this is called the experimenter. That means here we have to execute lots of algorithms at the time of at the same time. In the Explorer, we can able to check out implement so only one algorithm in the Explorer. Okay, so next to go for that, just so these are the main things here. So next to go for that workbench. Yes, knowledge flow and workbench also is the same thing, but what's the difference between that knowledge flow and workbench means? Yeah. So actually it will take some more times loading. Just a minute, I click just a minute. So workbench and the knowledge flow is nothing but, so the corresponding the workbench, yeah, just how to view this framework. So that workbench means it is consists of all menus. So what are the menus are available from Explorer and what are the menus are available from the experimenter. So everything is available in that one frame set. So which is called the workbench. It means it consists of, it integrate the everyone tools and the menus here. So which is called the workbench. So the last one is simple CLI. That means like a Python. We have to view. I will show that commanding line. So this is the commanding line framework. Here we have to execute any one commands. Just we have to execute any one function using the command, which is called the simple command line integration. So this is all the overall graphical user interface about that Vega tools. Okay, now let's go for that Explorer. How we have to execute one recursion algorithms or classification algorithms using the Vega tool. Just I have to show some practical session. Okay, just you have to click the Explorer, because if you are going, whether you are going execute only one algorithm means just you have to choose your Explorer. Suppose if you are going to execute more than one algorithm, that may be a 5 or 6 or 7 means just you have to choose in the experimenter. So now just we are going to execute only one. Just we are going to apply that only one algorithms in the data set. That's why we have to choose an Explorer. Okay, so this is the framework of the Explorer. Okay, now just we have to load that. So here that open file, so which is indicating. Okay, just I will click it. So here, suppose if you are having already, you are having any one data set means you can click that open file. Okay. So if you are the new user for the Vega means already the lot of predefined data sets available while you are installation the Vega tool. So for that, just you go to that C drive and click that program files. Then click that Vega 3.8.6. Then click that data. So here lots of predefined already static data sets are available here. So moreover, it is having that beyond the 20 about 20 data sets available. These are the default data sets available with that with our Vega tools. Okay, so these are things. So here, suppose if you are having any URL means you are any data set in that any URL means web pages, your blog, something like that. Just you have to choose that open URL, something like that. You can use that URL ID, and then automatically will take the data sets. Then if you are having that any data sets in that database means just you have to go for that OpenDB, then command something like that. So these are the indicating about how we have to load the data set. Okay, now we go for that. Just I click it. Just I go for that one simple data set. Okay, just I have it. Okay. Okay. So now I have to load it. So what we have done still now, just we have to open the Explorer, then just we have to click that file, it's automatically it's executed here. That means just the executable means just we have to that means just the data set is implemented here. That's only performed. But still now we didn't apply any one algorithms, any one data science algorithms or any one data science techniques here. Still now we didn't apply that. Okay. Now we have to compare between Vega and Python. Okay, so to done this steps in Python, we have to write the coding. That means just we have to import the pandas, sklearn, and matplotlib, and Seaborn, something like that. And we have to load that data type. Just we have to write the coding to load the data corresponding data set, something like that. Here, just we have to drag and drop. That means just we have to open the file and automatically just we corresponding that data file is stored for us. Okay. So here, how many attributes are there? Means here totally 5 attributes. Here this indicating outlook is 1, temperature 2, then humidity, wind, place. So these are the 5 temperatures here, 5 attributes here, as well as 10 instances. Okay. So if you come for that right side, okay. So if I come for the right side means here that label is indicating sunny, overcast, rainy. So it is a count of 4 and weight is 4, something like this. It is indicating how many instances are there. It is indicating here, as well as in the right side. So the corresponding data types. So it is a nominal data, the numerical data. That means sorry, these are the nominal data. So it's called the type is a nominal. Then come for that missing. So now we have to check out with the Outlook. That's why here there is no any missing value. It's called that 0. So the 0%. Then just we have to click the temperature. Okay. So here on just we have to check out that here also there is no any missing value, something like that. Then it is find out the maximum, which one is a maximum value, then which one is a minimum value, then find automatically calculate mean. That means the average number of sum of average, something like that. Then standard deviation, there is a cheapest value. Of that, this is called the standard deviation. It's automatically calculated. In the same time, if you are working with Python, Jupyter means just we have to click on data.info, data.get, data.mean, something like that. Just we have to write the coding in that Python, but here is automatically is created. So now come for that humidity means it's automatically show that. So it is a minimum, something like that. Okay. So here, so what is the motivation of this data set means? Here we have to check out in that sunny. That means suppose if the weather may be a sunny or weather may be whether is it a overcast or the rainy time, we can able to play in outside or not. Okay. So that is the there is a situation that the corresponding data set shows this situation only. So finally, the play is a corresponding output. So here they will give the 50-50 options. Okay, so we can able to go whether we can able to play in outside or whether or not, something like that. So it is given the 50-50 options. Corresponding the red is indicating that there is no possibility to play in outside. The blue is indicating there is a possible in that that we can able to play in outside, something like that. So this is that corresponding logic about this data set. Okay, so now we can able to understand how we have to load the corresponding data set and how we have to find out missing value, something like that. Okay, so now we can understand one thing, how we have to load the data set. Now we go for that, how we have to create a own data set. Suppose somebody have that somebody anybody have some your own data set because for your research problems or something like that. We are suppose if you are working in any one company, anyone MNC company or any one institution or industrial company, that means you are having some own data. So at the time, how we have to create that own data set? That means I will show that one more example for you. I will show that which one is we execute the last one. Okay, so now we can able to see that data set. Just open your text and then write it like this. So these are the procedures that we have to follow while we are creating our own data set. Okay, so the relation is indicating about that at relation is indicating about that may be a relation of our data set. So here we have to conduct the weather situation. That's why we have to given the weather relation. Then how many attributes? Actually, this data set consists of 5 attributes. The first one is outlook, second one is temperature, third one is humidity, then windy, then play. Here, so actually it is a label data set because it is having that output. That means the output is yes or no, something like that. We can able to play or no, yes or no, something like that. Because it's a label output because it's having a independent data. That means input data and the output data. Because always the output data is dependent upon, it is maybe a different data is based upon the independent data. That means always output is dependent upon that inputs. Here, so this data set is here supervised. That is a label data because it is having input as well as output. Okay. So here, suppose if I am going to create the 6 attribute or 7 attribute, just we have to click it /attribute. Okay. So attribute something like that, whatever may be. Suppose why we are given this real. So the real means it is a numerical variable. That's why we are giving that real. For example, just you have to 85, 80, something like that. Here, humidity is here 95, 90, 83, 58, 78. These are the real values. So numerical. That's why we are giving as a real. So this is a procedure. At last, at data. So what are the data we are going to given here? So this is a format of when you are having any idea to create the own data set, just you have to follow this procedure. Okay. So now, still now we have discussed about that, how we have to load the data set in Vega platform, then how we have to create our own data set. Okay. So next to go for that. Okay. So next to go for that, just we have to suppose if you are having anyone, for example, just I will show here. Okay, so this is one of that CSV file format. So we can able to upload. Just we are able to execute that ARF format as well as CSV format also. So here in that humidity, okay, here is a one missing value. Okay, so how we have to replace this missing value? Just we have to wait it. I will show you. So already I have that the corresponding this one. CSV file. Just you have to choose it. Suppose if you are going when you are working with loading our data set, just you have to choose in the format. So here these are the formats working with data Vega tool. So the first one is ARF. I am maybe always the corresponding Vega's data set is format like that .ARF tool. Then we can able to execute that CSV files also. Okay. So now I am going to execute that CSV file. Okay. I already have that page one. Okay. Now I load the data. Okay, from that page 5, estimate which one is having the miss value, humidity. Now in that outlook there is no any missing value here, as well as in temperature there is no any missing value. In humidity it's having that 10% missing value. That means we having the one value which is missing. Okay, something like that. So how we have to here I have to convey one thing at any situation, because actually this is one of the small size data set. Okay, so we can able to find out which one is which one data attribute, which one data is missing or there something like that. But anyone, if you are taking that any healthcare data set or anyone cyber physical data set means it's having a lot of, it may be a lakhs and lakhs of data set available. So at the time we can't be able to find out which one data is missing or something like that. Okay, so for that reason we have to follow the lots of procedures here. Just I will show you how we have to find out the missing value, as well as now we can able to find out how we have to missing value, because already if you click any one attribute, it will show that how much percentage of data are missing. That means how many data are missing, something like that. We can able to find out. Okay, so how we have to rectify these values? Okay, so just to go for that, filters, then go for that, because it is a supervised algorithm. Okay, just mean attributes. So we can able to find that. Just mean, yeah, I go for that instances. Yeah, yeah. Remove with the values. Just again, once again I have shown here. Choose, go for that filters. Then here that is a supervised and unsupervised algorithm, sir. Suppose if we are choosing an unsupervised algorithm, means go for instance. Then here remove with the values. So here we can able to replace the value by three things. Just I have to show that presentation. Yeah, okay. Okay, just I have to execute. Just I will show you. Here, just okay. Remove with the values. So the remove with the values means actually it is just I have to convey the two things here. We can able to replace the corresponding missing value by two types, maybe more over types, but I have to here I have to keep only two types. The first one is we have to remove the missing value with the values. That means it's automatically remove that corresponding data. Okay, so never ever anyone does not suggest this option, because the everyone data is more important in our data set, because if you want to find out the corresponding find out that more accuracy means just we have to consider every data's value. That's why so anyone does not concentrate or not interested to using this remove the values, because it's automatically remove that values. Apart from that, we have to using that remove the values with constants. Otherwise, remove the value. Remove the values with the means mean means just you have to find out that mean value, then replace that null value or replace that missing value there within mean value. Okay, so always the data scientists keep that fill with mean or remove with data constant, something like that. So that in any one situation, the data scientist does not follow this remove with values, because it is everybody know about that. How much, what is the value of the every and each and every single data, because it's based upon that our output, our performance is fully based upon our input data. So that's why anyone data scientist or data analyst does not using this remove with values. But okay, just for our example, practical session, just I have to execute this one. Okay, just remove with values. Just I have to choose one. Okay. Yes, I applied here. Now again we have to check it. Outlook, there is no any missing value. Temperature, there is no missing value. Then humidity, there is no missing value. Before that, there is show that 10% missing value. One value is missed here in that data set, in the humidity attribute. But now we have what we done. Just we have to remove with value. Just we have to choose that remove with the value. That means automatically it will delete that value corresponding data from the data set. Okay. So now we can able to find out there is no any missing value. So here now just you have to compare Python as well as Vega tool. Okay, so just you have to write the coding. Just you have to write the 2 lines or 3 lines coding to find out that what are the values are missing there and how to replace that value there. Okay, here just we have to choosing just what we done, just drag and drop only. Okay, now you can able to just you can learn how you have to handling that data pre-processing, how we have to handle that missed values. Okay, something like that. Okay, so next I will execute some classification algorithm, some regression algorithm. Before that, I will explain for that feature selection, how we have to handle that feature selections. First of all, we should know about that. So what is meant by feature selection? So that means we have to choose the particular attributes in any one data set, because the data set consists of lots of columns, lots of rows. That means like we have in the lakhs and lakhs of data there. Sometimes we confuse it. So which one data are most important, which one data are important, which one data are most important, something like that. Okay. So here we have to find out, we have to understand. So which one our data sets performance, that means our experiments performance depends upon which attributes or which data. So here we have to choose. So what are the important attributes? What are the important data? So we start that feature selection. So how we have to apply that feature selection here? Okay. Once again, I go for that. I will show that. Sorry. Again, I go for that Explorer, and I will show you from the beginning. Yes, I choose the Explorer. Okay. Then open file. So now I take that some data set from that default one. So C drive, program files, then go for Veha, then data. Here I choose that diabetics. So this is one of the data set. Okay. Now we can able to find out how many attributes are there. Totally is having that 9 attributes. So what is that intent of this data set? What is the meaning of the data set means? Suppose any one person having that diabetics is based upon that glucose or age, something like that. So it's also having that 8 input and 1 output. That means 8 independent variables and 1 output variables. The corresponding that class is the output variable is dependent upon that corresponding independent variable. So it's also labeled data because it's having that input as well as output. Okay. So now just you have to check it together here. It's a pregnancy, it is a plasma, then presence, skin, insulin, mass, prediction, age. So everything is totally the corresponding data set consists of 9 attributes. Okay. So here just you have to once again check it. If pregnancy having any missing value, no, there is no any missing value. Then plasma having any missing value, there is no any missing. First of all, before you executing, before you apply your any one algorithm here in the Veha tool, first of all, not only Veha tool, in data science. In commonly, if you are going to apply any one procedure or any one policy on the data science, just we have to do the pre-processing. That means just you have to check out whether how many duplicate data are available there, how many missing values are available there, how many so any gases or something like that. So before that, you have to whether you check out that this is a labeled data set or unlabeled data set, something like that. Just these are the pre-processing. Just you have to consider before executing any one procedures in the data science. Okay. So here the 9 attributes are available. Okay. So just I have to visualize that all data sets here. Just you have to just I have to click it visualization on. Okay. Here you can able to the bar chart. You can able to see the bar chart. Okay. So here also the last one is class. The blue is indicating 500 and the red is indicating 268. That means in this corresponding data set, the 500 candidates does not affected with diabetes. The only they are affected with 268 persons only affected with that diabetics. Okay, so this is that output of this data set. Okay, so here how we have to choose which what are the main attributes. How we have to choose here means just go for that filter. Attribute selection. Okay, so just you have to choose the filter, then go for the supervise and go that attribute. Here the attribute selection. Now we can able to find out the definition of the supervised attribute filter that can be used to select attributes. That means automatically it will find out. So what are the main features? What are the main attributes are executed? Will provide the corresponding performance. Okay, just I have to click that attribute selection. Sorry. Okay, now we have to apply here. Now see that here left side. So still now the corresponding data set having the 9 attributes, the 8 attributes for input. The last one is a class, is the output. Okay, but here only 5 there. So only that 4. So that means if you like if you get it that the good accuracy from the data sets, these are these attributes only enough. That means the 4 attributes only enough. So this is called the feature selection. So always nowadays you can able to, suppose if you are any research scholar, any person means any doctoral persons are here means that you will know about that. Everyone know about that what is meant by feature selection. So this is that called the feature selection here. We can able to execute this feature selection like this. Once again I have to execute that. Just you go for the filter, choose that, then you click the filters, then click the supervise, then click that attribute, then go for the attribute selection. Okay, so this is the procedure to apply our feature selection in the Vega tool. Okay. Okay, so still now we have find out how we have to load the data set, how we have to using data pre-processing. That means how we have to find out the null values and how we have to replace that values using the Vega tool. Then how we have to do the apply that feature selection, something like it. Okay, so now let's go for that. We have to apply some supervised algorithms in any one data set. Okay. Okay, now just I have to execute this the same data set. Okay. Okay, so now we done that all data pre-processing on the same diabetes data set. Just to go for that, suppose before that, just we have to analyze the data set's nature. So whether it is a labeled or unlabeled, which one algorithm, which one procedure you are going to apply on the corresponding data set. Okay, so in the top side, you can able to cover classification algorithm, cluster algorithm, association algorithm, something like that. Okay, so now go for that classification. Okay, so in the left side, test options. Use training set means, suppose if you are choosing this answer means corresponding the entire data set, the corresponding the Vega platform will treating as training process. Okay, suppose if you are clicking supply test set means the entire data set is executed for a testing purpose. Then cross validation. Okay, so here we can able to do the cross validation 10 times or 20 times, something like that. Okay, so the last one is percentage split. Okay, so always we have to follow that percentage split. So that means first of all we have to train the data set, as well as after that we have to test the data set. Okay, in previously just here also just I give some outline real-time example about the Tesla car. In the first time of launching, that means test driving the Tesla driverless car, automation car in that real time, they caught it that lots of accidents. Okay, so that means there is a lack of training for that automation car. Okay, so after that they will again and again train the car like that. Okay, so here automation purpose, here always just we have to give the 80%. Okay, so 80% for training purpose, then remaining 20% for the testing purpose. Okay, suppose just we have to give more options. Okay, so something like that. Here always just you have to consider, because due to the lack of time, just I even that only the main important things only here. Just to go for that once again, just to click that more options, just to go for that output predictions, because just you have to choose the plain text, because the corresponding output is shown in the plain text space. Okay, now click that OK. Okay, so now we are going to choose that any one classification or regression algorithms on this data set. Okay, just go for choose. Okay, now we can click the classifiers. Lots of algorithms here. So these are the decision tree algorithms. So these are the naive Bayes algorithms. So these are the functions indicating that logistic algorithm, actually the two linear regression is deactivated here. Okay, so simple logistic algorithm, then STM, simple vector machine algorithm, something like that. Okay, so now just for example, just I have to execute that J48. Okay, just we have to click that. Now we go for that start processing. Yeah, you can get that output of that corresponding data set. So here we apply that Vega classifiers decision tree J48 algorithm. the corresponding data set name is FEMA diabetes. Nowadays the analysis again is having this corresponding symptoms, I think so. How many instances are there? 768 instances are there here. Then 5 attributes, because previously 9 attributes is appeared, because after that just what we done, just we have to using that feature selection. We have to apply that feature selection methods. So that's why we get it only 5 attributes here. The 4 attributes input and last one classes here output. Okay. So here the 80% is here training purpose. The remaining 20 is here test purpose. Just you can able to see here, split the 80% to train, remaining test. Okay. So here it is applying that J48 teach entry algorithm. That means everyone know about that. What is the logic of the teach entry? Okay, it's applied here, step by step procedures. Okay. So the number of leaves, 15 number of leaves. That means the J48 algorithm is applied on the corresponding data set. The corresponding data is divided into 15 leaves and 29 trees. Okay, within the 0.14 seconds. Okay, that means corresponding program is executed within 0.14 seconds. Okay, here also give some real-time examples, real-time predictions. Always you have to consider one thing here, the data science, maybe we are working, maybe a data analyst or data scientist or whatever maybe. Okay, always just we have to consider one thing. 2 things we have to consider. The data science's result always may be it is a predicted, not confirmed. Okay, so this is your first thing. Second thing is always the data science is always there is no free-lunch concept. That means we can able to apply any one algorithm in any one data set. Okay, so it is called always just we have to remember 2 things while we are doing handling the data science project, something like that. Okay, so here some real-time project also. Actual is tested negative. The predicted also tested negative. So like that. Okay, so second one is tested negative, second also. Okay, so everything is okay. The third one is tested positive. That means it is actually the corresponding data set consists on data tested positive, but this algorithm is predicted. This procedure predicted is tested negative. Okay, so it is one of the problems are raised here. Okay, so like that. So how we have to recreate this one problem is again and again we have to use that lots of training session to our systems or products, something like that. Okay, so in just we come to the bottom side. Okay, it will show that 154 data. Just we have to leave it. Okay. Okay, so here also that summary, just you can able to view the summary. The corrected classified instances, 121 instances are correctly classified. That means what is original, something like that. So 33 is incorrected. Okay, so in like this I have to show that. Okay, so these are that. So these 2 are the correctly predicted. Okay, because the actually is tested negative, predicted is tested negative, but that one is a incorrectly predicted. That means it's originally is a positive, but it's predicted is a negative. So these are the incorrectly. So like that. So in that 768 data set, in the data set, 121 was predicted as a correctly predicted, and then incorrectly 33 only predicted. Overall, the performance is 78.57. So it is. So we can be able to appreciate about this output performance. Okay. So like that. Then mean error, then root mean square error, relative absolute error. So these are the base performance about this data set. Okay, so now to come for the true positive, then false to positive, then precision, recall, F measure, then MCC, ROC square. Okay, the class. Okay, something like that. Just you can able to the output of there. Let's come for that. Confusion matrix. Just place where the tested negative. That means 95 the first data, tested positive is 23, 26 in the 2 class. Okay, class A and class B. Okay, so this is the corresponding output while we are applying that text entry on that diagonal data set. So like that you can able to, suppose if you want to, just I have to show someone one more experiment. Okay, time is over, but even though just I have to show one more example for you. Just I have to show how we have to do the experiment. Okay, still now just you can correct some concepts how we have to execute it, how we have to apply any one algorithms using the Vega tool. Okay, suppose if you want to apply the cluster means just you have to choose here like that same thing. Just you go for that here. Okay, then association rules means just you go for that. It's defaultly applied tool is available like that. So like that here, go for that experiment. Just I have to show how we have to work with here. Okay, so here this is in Explorer we have to execute only one algorithms. Okay, in Experimenter we can able to execute more than one algorithms. Okay, just I have to give that. Just click it new. Okay, it's automatically appeared here. Then which one data set you are going to choose? Okay, add new. Okay, so here is already default there. Diabetics, just I have to use that. So the right side algorithms. Okay, so here they have to choose here. So I use again M5 rules. Okay, so these are the settings. Okay, based upon the condition or as well as environment, you can choose it. Okay, now just I have to defaultly. Again, I go for one more algorithms, Navy bias, something bias net, something, some always. Okay, a linear regression, something like that. Okay, apply that. Just come for that run, then start. Automatically started. Then come for that analysis. Then here the experiment. Okay, then pick the performance test. Okay, so here the two type of performances. Actually, I just you have to do something also. Oh, here go for that root mean square error. Just based upon the condition. Okay, it's a methodology. Just you have to work with Explorer and Experimenter. Okay. So I think so this is that outline about the Vega tools, because if you go for that, if you want in detail about the Vega tool, you can able to learn about it, but due to the time consuming, we can't able to yes, we can able to consider on the only outline about the Vega tool. Okay, so as well as it is enough for the beginners. Okay, suppose if you want to more some things about more about that Vega tool, just you have to browse a lot of YouTube search, a lot of videos available, YouTube, lot of websites available. Okay, so it's like that. So it is Vega is a one of so one of the platform to handle data science projects. Okay, so like that Python or something like that. So here I have to compare Python as well as Vega. Mean just we have to execute the programming. Then just we have to write the codings in that Python, maybe Python or another Python, whatever it may be. But in the Vega tool, everything is already predefined. Just we have to do that drag and drop only. Okay, so this is that outline about the Vega tool. Okay, suppose is anybody having some queries or doubts, something like that, please you can raise that. Yeah, please.
Sir, good evening, sir. Bhupati, sir. Good evening.
Yeah, good evening. Yeah, please.
You give a very nice orientation.
Okay,
sir, what I understood from your presentation was that Vega tool. Vega is a collection of machine learning algorithms. Correct? No, it's a tool of.
Yes, sir. Of course. Yeah. Of course.
Algorithms. See, I am.
Yes, sir. Of course.
Yeah. You see, there are so many algorithms. It provides so many algorithms. But I'm working on one biomedical application. As you said, you take one case study, nice example of diabetics. Okay.
Yes,
if I want to work on a particular disease, say for example, but how to select which algorithm is the best for my application? That's one thing. And in terms of accuracy, how to come to that conclusion? That's very important thing. So what do you say?
Yes, sir. Sir, first of all, so you have to find out the nature of your data set. Is it that labeled data or unlabeled data? Okay, first of all, just you have to find out the nature of your data set. Okay, because currently the two types are moreover always we are working with the researchers are working with the labeled data set as well as unlabeled data set. Okay, first of all, just you have to
say what do you say about diabetics data is a labeled or unlabeled data, sir?
Labeled. Actually, here is labeled. In this data set, which one is I have used? This is the labeled data set. Sometimes your data set may be unlabeled. Okay, maybe whether.
Give an example of unlabeled data. In what way it looks?
Unlabeled data means here. Just I have to show, sir. Just me. I have to show again. Again, I go for the same the diabetics. Okay, so here the class means the output. So which one data set is consists of output, which is called that label data set. Which one data set is does not have that output, which is called that unlabeled data set. So just you have to find out your data set is having output or not. That means result or not, whether it's having or not.
No, it must be having result. No, it must have correct any application. We want.
There is no need to which one data set consists output. Okay, so because sometimes so just here we have to give this data set for your understand purpose. Sometimes if I am in a researcher means just I have to collect the data from sensors or something whatever maybe. Okay. But I can't be able to put just I have to look out that which is corresponding which data set having that output or not. So please just you have to consider your data set is having output or not, please.
Okay.
So
Okay.
what are the yeah. So we first of all we have to consider that one. Yeah.
Okay. And what about you said the algorithm accuracy wise, which one is the best? Okay, I'm going to select the data set. Okay.
Yeah.
That is the
question. Yeah, of course.
After selecting the data set, then which algorithm I should apply? Then how to make it?
So that's why lastly I told one concept. There is no free lunch concept because data science always having that free lunch concept. That means we can't be able to predict it. So we can't be able to finalize which one the algorithm is best for which one data set. Okay, so we can be able to apply any one algorithm in that data set. Okay, so maybe before that just suppose if a data set consists of it may be a labeled data set. Labeled data set means just you have to choose that supervised algorithms. Okay, then you have decision tree, then assume algorithms, then classification, then regression algorithms. These are the supervised algorithms. Just you can apply that. Suppose if your data is unsupervised data, means just you have to apply that unsupervised learning algorithms. Just like that. What do I say? Lots of algorithms. I will show you, sir. Just a minute. I will show that.
No, only question is how to select which algorithm is best for my data set. That's the question.
Okay, sir. Suppose if for that, just I have simply first, just I have to give simple answer for you for your understanding. Suppose if your data set maybe whether maybe it is labeled data means just you have to choose supervised algorithms. Okay.
Okay.
Suppose if your data set is unlabeled data set means just you using that unsupervised algorithms. Just this for this outline. Yeah.
I understand.
So here I have given that some algorithms for your reference. Yeah. Please.
Okay. And one more thing, sir. No, people we are talking about deep learning kind algorithm. No, sir. Correct, na? Deep learning. Then how deep learning algorithm?
Deep learning. Yes, sir. Yeah, lots of algorithms are there. Artificial neural networks, conventional neural algorithms. There are a lot of algorithms there. But even though. So actually, before we are going to apply any one algorithm, any one prediction, just we have to first of all you have to consider three things, sir. Which one application we are going to work? That means application means there be a financial sector or medical sector or a cyber physical sector. Which one? We have to consider one thing. Suppose you are from medical field. Okay. So just first of all, just you have to consider that medical application. So after that, you have to choose it data set. Okay. Sometimes some researchers are taking that predefined static data sets. They actually that is already available from anywhere. Okay. For example, COVID-19. Lots of data sets are available for the COVID-19 here nowadays. Okay. So otherwise, suppose if you are having the own data set. Just you have to collect some data from anyone hospitals or medical units, something like that. Okay. Here just you have to consider that maybe already available data or it is a own data set, something like that. Okay, just you have to consider. After that, just you have to consider which one algorithm you are going to apply there based upon that application as well as data set. Okay, because even though suppose you are maybe someone may be the beginners means the lot of confusions will arise. because we are the beginners. We can't
Okay.
able to do we can't apply the directly that. Okay. So for that reason, just you have to refer some papers because your research is already some it's having some reference already.
Okay.
For example, nowadays my one of my friend is doing that working with gradient boosting algorithm, which is feature selection. Okay, so this concept is having some reference in previous year. Okay, just you have to refer that. So which one they are already applied, already applied. So what is the output, what is the accuracy of that algorithm somewhere. After that, just you have to consider which one which one algorithm is suitable. Suppose you hereafter, just you have to refer that previous one, you will get it a good idea, sir, clear idea, sir. Yeah.
Thank you very much, sir. Thank you very much for your nice explanation, sir. Thank you.
Thank you, sir. Thank you, sir. Thank you. Is anybody, please?
Sir, good evening, sir.
Please, sir, please.
So how far Vega tool is good for unstructured data, sir?
Sir, please, once again, please.
How far Vega tool is good for unstructured data?
Unstructured data. Yeah, you can able to apply that. Yeah.
It is good for using Vega.
Once again, I have to repeat. If you consider about data science, because from the industry, actually it is a slogan from the industry. Before, while you are considering about the data science, always just you have to keep it one thing. Again and I can tell you, there is no free lunch concept, so we can't predict it. So whether this is a right one or this is a wrong one. Okay, so so if you consider about data science, just we can be able to apply any one algorithm or any one application, something like that. Okay, so always the data science only provide the prediction only, not accurate. Just we have to consider these things. That always it is a predicted. Tamil சொல்லுவாங்க யூகிக்கிறதுன்னு சொல்லுவாங்க. So always it will be a predicted. It's not a complete. Okay, so it is suitable for that unstructured data, that unlabeled data also. So just you have to load it and check it whether it is best or not, something like that. Suppose if it does not provide the best accuracy, just you have to choose you have to apply that feature selection. So what are the best attributes, something like that. Just you have to choose it. Otherwise, suppose if it does not provide that what you expected, just to go for that another tool. So Python Jupyter or Python Spider, something like that. Just go for other. Lots of tools are available in that current market. Yeah, please.
One more question, sir.
So I am always please, Adya, please.
Can data augmentation can be done in Vega tool, sir?
Hello.
Sir, please.
Data augmentation can be done in Vega tool.
Hello, sir. Am I audible to you?
Sir, please wait, please. Sir, please. Data augmentation.
Yeah. Data augmentation.
Yeah, sure. Yes, of course. Yeah.
I want to increase my data. Yeah.
Yeah, of course, sir. Of course. Yeah, of course.
Okay, thank you so much, sir.
Thank you.
Hello. Sir.
Please, sir, please.
My question is that, can I,
please.
since you have displayed the Vega, you have demonstrated Vega tool, can I use Vega tool as an alternative to Python?
Yes, sir, of course. Actually, I am always not recommend Vega tool. I am recommend Vega tool. Okay, but even though based upon the condition, based upon your data set condition environment, just you have to choose the Python. Just you have to choose the tool, because here tool selection is most important for your. Suppose if, sometimes you are doing your research work, means just you have to choose which one is the best. Okay, always Vega is a pretty different concept, the track and trap. The Python is that means what I try to convey means, if you get it your output, if you get it your performance using the Vega tools, you can use it. Okay, so otherwise just go for another tool. Okay, always just I am not recommend Vega tool, but even though you can use the Vega tool, but I am not always not recommended. Okay, I can recommend, but not always. Yeah. Please, sir. Please, is anybody there? Sir, anybody for your queries, please?
Good evening, sir.
Good evening, ma'am. Please, ma'am.
Yeah. I want to know that how can we use the decision tree algorithm whenever we are using the classifier option, classifier
Decision tree algorithm.
Yeah.
Decision tree algorithms. Yes, ma'am.
Are you here?
Yes, ma'am. Of course. Yeah, please.
How can we use the decision tree algorithm whenever we are using that Weka tool?
Yes, ma'am. Just to go for this, I have to just view my screen. Go for classification. Then choose that. This is a classifier. So this is a decision trees. Please. Once again, I got okay. Okay. Now, let's go for the classification. Choose that. Choose one. The last one, the rules. This is that it's available. Sorry. Trees. Yeah. Trees and stem. Found filtrate, J48, LMD, random forest, random tree, rep tree. Okay, just now, previously we used J48. So now we choose a random forest. These are the decision tree algorithms. Okay, they're just we have to start it. Yeah. Now we got it that output. Yeah. Yeah. Now we got it output. Yeah.
Sir, one more thing. How can we make a decision tree in Weka?
How will you make a decision tree?
Yeah.
Please, actually, ma'am, these are the predefined algorithms are there here.
Okay.
Once again, I repeat you. In Python, we have to write it the coding. So which one we want, just we have to write the coding for our. Suppose we want the logic regression, just we have to import that logic regression from that encoding, one-hot encoder, something like that. Just we have to using the Python like that. Here, everything is predefined. So that means just we have to do a drag and drop only. Okay. So what is the main motivation in terms of this Weka tool means? Anybody from the computer science domains or IT domains means they are having some more knowledge in Python tools, something like that, some program knowledge or MATLAB, something like that. But some researchers are doing data science projects. Apart from that, IT, CSE, suppose if anyone from that mechanical or civil means they does not having that in-depth knowledge in Python or something like that. So that's why to rectify these problems, they are provided a Weka tool. Okay, for simply drag and drop. Okay, so like that, just we have to execute what already present here in Weka tool. But Python is not like that. We can able to execute by coding anything in the Python. There is a difference between them. Yeah. So it is a predefined one thing. Yeah.
Okay. Okay. Thank you, sir. Thank you.
Yeah. Thank you. So once again, also just I have to give one more example for also. While we are applying that the decision tree concept, so at the time we got it the output. Okay. Now we have applied the decision to random forest. Now we have also got the different output. Okay. So always that data science always to be a prediction only. It's not the accurate only. Just we have to consider. If you are working with, if you are working with anyone data set means, but just first of all, just we have to choose which one application you are working. Second one is which one data set we are working. Then after that, just you have to choose which one algorithm and algorithm plus feature selection, something like that. Okay, so then only. So first of all, just you have to consider these things for your research purpose or whatever maybe. Yeah, please. Is anybody please?
Sir, good evening, sir.
Good evening, ma'am. Please, ma'am.
Sir, actually, I already worked in Jupyter, Spider, a lot of tools.
Okay, ma'am.
Only I observed that Weka Explorer tool. It's very nice tool. Drag and trap.
Okay.
And also already is built in that some of algorithm in that Weka tool is very excellent.
Okay.
If you can you say which beauty for that compare the Jupyter and Spider, Python. So which one is that is graphical user apart from which one you are like in Weka tool, sir? Because you are saying that already for example Jupyter, Spider, Python compared to you just write something code. Because if you are using already inbuilt, that is predefined.
Yes,
algorithm we are defined. How many algorithms we are defined in that Weka tool? So which the compared to the other tool in Weka special than?
Yes, ma'am. Of course, I will show that. So how many algorithms are present at predefined here means Just go for a classification. Just you choose please, ma'am. Just you have to see that how many algorithms are. If you click that bias, so this much of algorithms are defined here. If you did functions, these are the regression algorithms. Here they are doing that. If you go for lazy, okay, then meta. Here that means filter classification, multi-class classification, updatable. Then go for the efficient tree, lots of that. If you come to the cluster, here just you have to
That is means learning. We can apply for the cluster concept. If it is the data inset, that is unlabeled structure, we are using the cluster concept. Okay. Super,
yes,
sir.
Yeah. The cluster algorithms are there, associated algorithms there. So then it's the main difference. Means like I think this will be a good answer for your question. The main difference between the Python and the Vega means everything is pre-defined here. Everything is pre-defined here.
Because if we are using in the Jupyter, we are imported in some one line of code.
Yes, ma'am, of course.
Null value, everything we are put in some line, one single line. But here there is no. You just click it, it will be show that.
Yes, ma'am, of course. Yeah. But even though compared with Python, Vega is have some issues, some demerits, because you can't execute what it feels. Yeah. That's a problem here. That's a problem. In Python, we have to execute in Jupyter. Compared with Spider and Jupyter, we can able to execute. Just Jupyter is a very good package working at the time of working in time. Compared with Spider as well as Vega. Yeah, but Vega is given a limited sources only. Yeah, Vega is given only. Yes, ma'am. Of course. It is having the limited sources only. Yeah. Yes, ma'am. Of course. Yeah, of course. But Python is whatever you want, just you have to export in Python. That is one major demerits of Vega. Yeah.
Okay, sir. Nice, sir.
Oh, thank you, ma'am. Thank you. Is anybody, please? If you have any queries, please.
Indusha?
Yes, sir.
And you can conclude the session. Indu.
Okay, sir. Hearty thank you, sir, for such a comprehensive and instructive session. And participants, tomorrow 7 to 8 p.m., Dr. M. Subbaiah, data science practitioner, Rapo Physical Commerce, Chennaitis will be explaining Scikit-learn, Matplotlib, and Plot. Kindly fill the feedback sheet circulated. On behalf of our department, everyone gathered here today, I express our heartfelt gratitude for Bhubadi sir for accepting our invite and facilitating an enormous knowledge sharing session. Thank you so much, sir. And
thank you.
Participant, yes, sir. Thank you so much.
Thank you, Bhubadi sir. Thank you very much.
Thank you, sir.
And participants, thank you for joining us today.